right-angled triangles. If x plus y is always 6, what's the biggest possible area? So we know that area is 1/2 base times height, which would be 1/2 x times y, but we want to get things in one variable. So if the two of them always equal 6, you can get y by itself. And then you have an equation for area that's just in terms of x. And all of our optimization questions, we find the derivative, set the derivative equal to 0. So that means x has to be 3, y would also be 3, and the maximum area would be 4.5 centimeters squared. So again, all of these optimization questions, it's about what are we trying to optimize? That's the equation we want to make. We need to make that equation in only one variable so that we can do the derivative. Because if you had two variables, then you would have implicit differentiation and more like related rates, complicated. So that's our plan. Find the points on the curve of the square root of x that is nearest to the point 3, 0. So here is a picture. And we want that distance to be the smallest. Obviously, if I picked a point over here, that would be longer. So what point will give us the shortest distance? Ooh, did we just set up an optimization question? We wanted the shortest distance. The shortest distance between x, y, and 3, 0. And did you see what I did with the y? Y would equal the square root of x. So now I'm dealing with one variable. Do you remember your distance formula? Okay. Technically, your distance formula is just a squared plus b squared equals c squared. So if you've forgotten your distance, check this out. Make a right angle triangle. What is this length? It's the change in your y values, which is going to be the square root of x minus 0, because that's the change in my y values. What's this length? That's my change in my x values, which will be x minus 3. If I did this point first, I have to do that point first in both of them. A squared plus b squared equals c squared, right? Do you notice in the distance formula that they have the x minus 3 squared? They have the square root of x minus 0 squared. And then why do we have a square root? Because it would equal c squared. And if you wanted to find c, you would have to square root it. So you could rememorize your distance formula. Not recommended. Or you could just say, I already know a squared plus b squared equals c squared. If I ever want to find the distance between 2 points on a line, I could just use that. Right? Because we're just using if a squared plus b squared equals c squared, then c would equal the square root of a squared plus b squared, and that's your distance formula. We want to minimize the distance. So what do we need to do? We need to take the derivative. Special note to make this easier. If I want that to be the smallest, it's going to be the smallest whether I have the square root there or not. This will make our life easier because I'm just going to solve the derivative of the inside. And I get x equals 5 over 2 as a critical point. How do I know that that's a minimum? I could draw my number line, just like we did in curve sketching. And my derivative is negative before 5 over 2, positive after, makes it a minimum. So then if my x value is 5 over 2, then my y value would be the square root of 5 over 2. And that would be the point that's the closest to 3, 0. I think this question's a little bit harder to see that it's an optimization question because it didn't say find the maximum or find the minimum. It said find the point nearest. Okay? Well, that kind of implies you want it as small as possible so that you'd have to realize this is an optimization problem from that. Often these questions are calculator questions. Sometimes we skew the answers to make them non-calculator. So you just happen to know that this has a volume of 54 pi centimeters cubed. There is a picture of our cylinder. We want to show that the surface area of this cylinder can be written in this form. Well, what is surface area of a cylinder normally? Normally, surface area of a cylinder, oops, that's too many boxes that I'm going to undo that. I wanted to only show you this one. There we go. Normally, your surface area of a cylinder is 2 pi r squared plus 2 pi rh. Problem with this is we have two variables, r and h. In part B, we're going to want to find a minimum surface area. So part A is saying, can you do the math to get rid of the h? And in optimization questions, they'll often give you another piece of information. They gave us the volume, which we have a volume formula. We could plug in the volume that we know, and then we can either isolate the r or isolate the h. In this case, it's easy to isolate the h. Well, the pi's nicely canceled out. And then once you've isolated the h, you could plug that in for h in the other equation. And what we've successfully done is we now have this equation for surface area that's only in terms of one variable. So if we want to find the minimum in part B, we just need to take our derivative, set it equal to 0, and solve for r. That's our equation. See how I move the r up as r to the minus 1 to make derivative easier? Find your derivative. Set it equal to 0. And use your algebra skills to solve. So I multiplied everything by r squared to get rid of that denominator. Divide and cube root. And it works out so nicely because they made this a non-calculator question. And once we have r, it said find the radius and the height, so we still need to find the height. whenever I do questions like that, I'm like, ooh, it's double. Does that always happen? If I picked a different volume, would the radius and height still have that relationship that they'd always be double? Or is it just coincidence in this situation? And our last one. All right, Canadian Postal Service will accept a box for domestic shipping only if the sum of the length and the girth, which is the distance around, does not exceed 108 inches. You can't ship things too big with Canada Post. Then you have to choose different shipping options. So if you wanted to send a new vehicle to your friend, probably is not going to happen with Canada Post. Yes. Perimeter, yes. Circumference is only for circle. But yeah, the perimeter of this y plus y plus y plus y. In other words, the x plus 4y's at most can be 108. Can you see it's really easy to get x by itself? By moving the 4y over? So basically what they're saying they could do with their packages, they take a measuring, like one of those measuring tapes that's like plastic, not like cloth kind of thing. Wrap it around, see what that measurement is, see what the length is, and then as long as it's less than 108, you're fine. We want a maximum volume. Question?
Where'd you get 4y?
The box has a square end. So if you added, the girth is going to be this. The perimeter around the one side. And this is my length, which is x.
Why isn't it 4? Or
Y plus y plus, since this is a square, all four of these sides are going to be y. If I measure around, y plus y plus y plus y will be 4y. Good? Now my volume is going to be length times width times height. You see that that's going to be x times y, or x times y squared. And now I've already got x by itself, so I can plug that in, and then I get an equation with only one variable. Now the optimization becomes easy. Once you get your equation of what you want to optimize, we want to optimize volume, we want to find a maximum volume in one variable, then you can take your derivative, set it equal to 0, and solve. Now, you get two answers. You get y equals 0, and you get y equals 18. How come I knew to put an x through y equals 0? Like, 0 would not be a very good measurement for a box. I'd like to ship this. How much will it cost? You go there with nothing. They look at you kind of funny. What would you like to ship this? I would just make up a huge amount of money. No, you could even chip it for very cheap, $10. Okay, give me $10. Yeah, delivered wherever you wanted that chip to. They now have it. So if y is equal to 18, you could solve x, because x plus 4y has to be 108, which tells us that x had to be 36. So the length is 36. This is not the girth. This is just the width, is 18. And you could show with your number line that 18, in fact, is the maximum because the derivative changes from positive to negative. Because it could be in a question where you get two values which are possible, but only one of those values is an actual maximum, the other one might be a minimum. And then they could do optimization problems that also involve extreme value theorem, right? Because you could have certain kind of endpoints that you'd also have to check.